Hello, my name is Deborah Behan, and I'm a secondary math consultant at Region 10.
Hi, I'm Andrew Burns, and I'm a secondary mathematics specialist at Dallas ISD.
Today we're talking about the real number system, and specifically the student expectation 7.2a. 7.2a will be in full implementation in the classroom in the 2014-15 school year and will be tested on the 7th grade STAR in spring of 2015.
7.2a is in the Numbers and Operations reporting category, and it reads, the student applies mathematical process standards to represent and use rational numbers in a variety of forms. The student is expected to extend previous knowledge of sets and subsets using a visual representation to describe relationships between sets of rational numbers.
While teaching 7.2a in the classroom, you will want to use the formal mathematics vocabulary in the list shown in part, including real numbers, rational numbers, irrational numbers, whole numbers, integers, natural numbers, counting numbers, terminating and repeating decimals, fractions, discrete, continuous, the property of density, set, subset, finite, and infinite.
Lots of vocabulary for that one standard. In the standard, it says that you need to be able to show visual representations describing all of the sets and subsets. And so here's a great one to use that shows the relationship among all of these that you see.
Another visual representation of the number sets includes the number line. To graph the whole set of real numbers on the number line will be a continuous set shaded to negative and positive infinity, or the entire number line. It has the property of density, meaning given any two numbers, there's an infinite number of numbers between those two numbers, and again goes to negative and positive infinity. The rational numbers are numbers that can be written in the form of fractions or terminating or repeating decimals. Between any two rational numbers, there's an infinite number of rational numbers that exists. The irrational numbers are mutually exclusive from the set of rational numbers. They're in the real number system but do not overlap with the rational numbers. Examples of irrational numbers include pi and the square root of any imperfect square.
We also have the integers, whole numbers, and natural numbers. So let's start at the easiest one, the natural numbers. Those are just the numbers that you learned when you watched Sesame Street or in kindergarten, pre-K or kindergarten growing up. Those are just the counting numbers, 1, 2, 3, 4, so on. It just jumps from 1 to 2 to 3. So that is discrete whenever you can jump from one number to the other. You're not hitting any of those rational fractions or decimals in between. The whole numbers are just the exact same thing as the natural numbers, but with 0 included. And then integers are the same thing as whole numbers, but with those whole numbers opposites included. So the negative numbers, -1, -2, +2, 0, those are all included in the integers.
In 7.2a, students are going to need to know the relationships between the number sets. The set of real numbers are made up of the rationals and irrationals. The rationals are a subset of the reals. The irrationals are a subset of the reals. Again, the rationals and irrationals are mutually exclusive. They're disjoint sets. The set of integers are made up of the whole numbers, the natural numbers, and their opposites. The whole numbers are a subset of the integers. They include the counting numbers and 0. The natural numbers are a subset of the integers. They are the counting numbers, 1, 2, 3 to infinity. The naturals are a subset of the wholes also. The wholes are the natural numbers and 0. The set of whole numbers are made up of the natural numbers and 0. The naturals are a subset of the wholes.
So Deborah, if we had a Venn diagram and we had rational and irrational numbers as our two circles, what would that look like?
That would be two disjoint circles that do not intersect.
Okay, so the circles don't even touch. And then where would all these other numbers fit in that Venn diagram in those circles?
The remaining sets of numbers that we need to know in 7th grade include rationals, wholes, rationals, integers, wholes, and naturals, and they are nested or subsets of one another, with naturals being the smallest set.
So would they be circles within circles within circles?
Concentric circles.
Concentric circles.
Not overlapping.
In the rational circle.
Within the rational numbers. None would be in the irrationals.
Some activities that you could use in your classroom to have some purposefully aligned instruction for 7.2a are a classification card sort, a classification table or chart, some poster categories, Venn diagrams like we just talked about, and also 3D Venn diagrams if you want to get creative. And Deborah's going to explain these in further detail.
On the left here you have classification in the form of columns where you can have your students, after providing some real number, you can have your students classify it in the different number sets. On the right you'll see an example of what you might do on your classroom walls in the form of posters on the walls with post-it note stickies, and students can classify numbers while walking around, and then you can do a gallery walk.
This is a similar concept to what Deborah was just talking about. You could also make a poster of these. They include all the sets and subsets of the types of numbers in the real number system, and you can just classify them this way. Use post-it notes. But you have to keep in mind that the post-it notes might go in more than one column.
Here's an example of a 3D Venn diagram activity that you might use in 7th grade. I guess this would be a 3D visual representation since we talked about the Venn diagram being circles. This is a great activity because it includes bundling of standards. Additionally, it's a good visual representation of subsets and where the number sets fit in with one another.
Right, so if you want a demonstration really quick of how this would work, it would really help those struggling students, so you might use this as a differentiation strategy in your classroom. So as you can see, the biggest box is the real numbers. If I try to put the real numbers in the rational number box, obviously that's not going to fit, right? And hopefully the student will realize, and they might need you to help them realize this, that there are more real numbers than there are rational numbers, because in the real number system it also includes irrational numbers. So we know that the rational numbers can fit inside the real number box because this is a subset of this. Rational numbers are a subset of the set of real numbers. Also, irrationals, like Deborah said, are disjoint. So in a Venn diagram it would be two separate circles. So this irrational does not go inside the red rational box. It fits right there. So two disjoint, they're not connected. Now we have naturals, integers, and whole numbers left. So we have to figure out the relationship among all of these different subsets. So the student can, it's like a puzzle. They can just try to figure out which one goes in which, but you need to ask them why. Why does that go in there? You can't just say, yeah, you figured out the puzzle. So they have to tell you why. Oh, integers go in rational because these are positive and negative numbers, but not fractions or decimals. And, well, yes, naturals go in integers, but is there a better way? Yes, naturals go inside whole numbers, and then whole numbers go inside the integers. So that's a great hands-on activity for your students.
Here's another two-dimensional visual representation of what Andrew was talking about. An example of a 7.2a question might be in the form of Walter is given the number -6/2 and expected to classify it into each number set that it belongs. Which set or sets should he choose? So Walter needs to understand that -6/2 can be simplified in the form of -3. -3 will obviously be a real number. -3 will also fall into the number set rationals. It will not fall in the wholes because it is a negative. It will fall in the integers because it is the opposite of +3. And that leaves us with answer choice B, rationals and integers. We've just discussed Student Expectation 7.2a. My name is Deborah Behan with Region 10.
And I'm Andrew Burns with Dallas ISD. We hope this video helps you in your instructional practices and helps all of your students succeed.
Thank you.